So we have arrived in the final section of this chapter, using the LLM as a spam classifier. This essentially means that we are now implementing a small convenience function so that we can use the model that we have just trained on new texts. For example, if we have a new text message, that we can classify whether this text message is spam or not spam. So in the grand scheme of things, where we are right now is we are here in step 10, we prepared the data set, we downloaded the data set, we loaded the pre-trained weights. Most importantly, we fine-tuned the model, we evaluated the model, and now we get to use that model. So for that, let me define a function called, let's call it classify text. One of these days I have to find a better keyboard position. I'm usually not such a bad typer. It's just because of the recording, I have my keyboard at an awkward height here. So of course, what we want to classify is the text. We will need the model. We will need the tokenizer to prepare our input data. We will need the device to make sure the data is on the same device as the model. We can, or we should define a max length so that we can say how much padding we need to make sure the examples are padded to the length that we, or that our model expects based on the training. And then, of course, when we talk about padding, we also need the pad token ID. And for that, we are going to use the end of text token 50,256. Now, of course, the first step to preparing the text is, of course, like always, encoding it, tokenizing it, getting the token IDs here. Then let me make a helper variable here. Let's call that supported context length. So here I will just assign this the length of the inputs that the model supports. Based on our configuration file, we know it's 1024, but to keep that function a bit more, this variable, the way we extract this information a bit more general, we can actually just get that from the positional embedding matrix, right? Because the matrix here, the number of rows is the context length. So that's what I'm assigning here. And then we can accordingly prepare the length of our input IDs. For example, if it's a very long tensor, right? So if it's very long, we might want to truncate this, right? So we want to truncate it down to supported context length, because otherwise the model will crash. And if we have a max length defined, so let's do it like this. If we have max length, it will use that one, assuming that the max length is smaller than the context length. So here it will now, I think I made a typo. It will now get whatever of those two values is smaller. So in our case, max length is 120. So it will use 120 and truncate them to 120 if the input IDs is, let's say, 200 or something like that. Now we also have to take care of the case where the input IDs are smaller, right? So if we have input IDs of, or token IDs, 20 of them in a text message, we want to pad them to 120 to make sure it's similar to what the model has seen in the training set. So I mentioned in the bonus material in the previous section that there are different ways of doing it, but in our case, the way we have set things up, the model always expects the last token ID at a certain position. So we have to make sure we apply the padding to make sure the position is always at the same point. So how do we do this? Let's do, I mean, there are multiple ways. Let's just do it simple here. We use the pad token ID, and then we calculate, let's do it like this. How many do we need? The max length. So if we have max length 120 and our actual length is, let's say, 60, it will add 60 tokens. So we can calculate the size just using length, because this is still a Python list. So if our input is 60, max length is 120, it will add 20 pad token IDs to our input tensors. Token IDs. Okay, so far so good. So one more thing, our model doesn't want Python list, it wants PyTorch tensors. So we have to convert this to a tensor. Inputs IDs, and then we can also specify the device. So it's directly initialized on the device instead of doing it like this. I mean, we can also do it like this, but doing it like this is even better because it will initialize it directly on the device. And then our model also likes batches. So we are adding the batch dimension here. Next, of course, the model needs to generate the logits. So let's do no grad because we're not training anymore. We get the logits based on the inputs IDs. And then, of course, we are interested in the last token. Okay, so that's what we have here. Most interestingly, we want the predicted label. And for that, similar to before, we can use the torch argmax on the logits. And then, of course, it's a 2D tensor, so we do a -1. What else? So next, I think this is it. So we can, based on that, we can actually return the prediction. So we have the predicted label, so we can just return it. I mean, we can return 0 or 1. We can directly return this, for example, as a number. We can also just say if it's 1, return spam. It's maybe a bit nicer. Spam if predicted label equals 1, and else not spam. And I hope this works. It looks good so far. And so we could technically now give it some sample. Let me just prepare some sample here. So here we have, you are a winner. If you are a winner, you have been specially selected to receive $1,000 cash or a $2,000 award. I mean, might be legit, but to me, this sounds pretty much like spam. Maybe I'm just like this person who always deletes these messages, but my first intuition would tell me in this day and age, this is spam. So let's see how good our model is doing. If I have, oh, no typo this time, if I have implemented correctly, and it does seem like I did everything correctly here. So we, or the model predicts that this is spam. So let's do another one. So let's classify, I have some other text here that will just provide. Let's classify another one. Hey, just wanted to check if you are still on for dinner tonight. Let me know. And this is usually, in my opinion, something that sounds legit. Of course, depends on the sender, but yeah, let's see what our model thinks. So in this case, it's not spam. And so with that, we have now a spam classifier that we can use. I mentioned before, you can put a nice interface on it, like this chainlet interface, or you can develop your own independent interface if you know some basic, web interface programming and so forth, whatever you like. So, but this is how the code works. This is what underlies our spam classifier, and it should, work now on text messages. Of course, you can also, if you're interested, extend this to other problems like email spam classification, document classification, all kinds of things. So, but one thing, if you want to use this later, one thing that might be useful is saving the model. So similar to what we have done in chapter 5, we can use the model.stateDict here and save the model. We can give it some name like review or text classifier.pth. In case you are wondering, in the book, I think I always say review classifier. It might be an artifact because I first worked with this movie review data set. So, and I figured out, okay, this is too large. It takes too long to train. It might be nicer for readers to work with a spam classifier. So maybe I should have just called it text classifier instead of review classifier, but in case you're wondering. And then, this will save the model. So we can go in here and see it should have, I don't see it right now. Oh, I'm in chapter 5 actually, because I think I had it open for something else. Here we can now take a look and see it's saved here as text classifier, and then we can load this in a new session. So if I were to initialize a new notebook because I'm lazy right now, I'm not doing it, but you have seen how it works in chapter 5. So we can load the stateDict with a torch load function, and then the name text classifier here. And then we can also say where we want to load this on our device that we have specified. And then this will load the state dict like this, and hopefully this works. All keys matched successfully. And yeah, with that, we have now our spam classifier that we can use. And this, I hope, was a nice introduction to fine-tuning, how we update a model that has been pre-trained. Just scrolling up, because in the next chapter, it's actually my favorite chapter, we will be fine-tuning the model for becoming a personal assistant, like instruction fine-tuning the model to do other things, not just returning class labels, but answering with full sentences and doing different types of things and so forth. So stay tuned for chapter 7, where we will be instruction fine-tuning the model.
Get this book at manning.com.